The Stratus LED 100-watt modules can be treated with silicone to be made water resistant for use in the rain or snow. Subject your LED modules to moisture at your own risk. We do not warrant water damages. You may notice the driver PCBs come with a layer of clear rubber coating from the factory. This does not provide any waterproofing. It's only for durability. When untreated LED modules do come in contact with water, they usually still emit light and run the cooling fans like they are supposed to. But the switch and on-off pin stops working, so they are basically stuck in the on position. But more about that later. To waterproof your modules, you'll need silicone waterproofing sealant. The stuff I'm using is made by Loctite. First, remove the 4 bolts and disconnect all the wires from the PCB. If you want to still use the on-off switch, mask it off with tape. Then, mask off the screw terminals and pins. Having fresh silicone is key. Using old stale silicone will be more difficult and less effective. Squeeze silicone onto the board and start smearing it around. It needs to cover every square micron of every part of the PCB, so use a lot of it. This is very important. Again, absolutely everything needs to be covered, even the edges of the board. This is a messy process, but it's the best way to do it. I like to wait until I reinstall the board onto the rest of the module to cover the backside. Even put silicone in between the fins on the heatsink. Slide the bolts back through the holes and reinstall all the wires. Be really careful during this step because these boards do not have reverse polarity protection, so if you plug any wires in incorrectly, the capacitors on the board will explode when you plug it into the battery. Give the wires a tug to make sure they are tightened down enough, then bolt everything back together. Don't over-tighten the bolts because they can deform the fan housing and cause the blades to rub. Make sure all the wires are pressed down and out of the way of the fan blades. You should install the jumper on the jumper pins so they don't get covered. Start globbing on the silicone and make sure everything is covered once again. Do the same to the backside. I like to use my finger to smooth everything out. This is a good time to go over everything again and make sure there are no gaps or holes. If you don't waterproof the lens section, water can seep in, so we'll do that next. Remove the lens pieces and inject silicone into the holes that the LED chip wires go through. Also cover the solder connections. Put a thin layer around the white border of the LED chips and wipe off any bits that get too close to the yellow area. Put the reflector back on and be sure to line up the 4 bumps with the 4 indentations in the LED chip. Sometimes you need to press down pretty hard to get them to snap back into place. Next, put the lens on and smear silicone around the gap. Then, tighten the lens bracket back down just enough to preload the metal tabs ever so slightly. The LED chips have metal tabs that stick out on the sides, and these can corrode if they get wet, so encase them in silicone too. Let the silicone cure completely. This usually takes between 24 and 48 hours. Your LED module should now be waterproof, although it's a really bad idea to submerge them completely. We ran 2 test modules underwater for 3 hours, and this is what they looked like afterwards. All the metal was heavily corroded. This is why you should only subject your LED modules to rain or snow at the most. You don't have to worry about the cooling fans because they're water resistant. The ones we left underwater for 3 hours during our tests still worked fine afterwards, but they just sounded a little weird. A lot of people typically use epoxy to waterproof circuit boards, but that will not adhere properly to the rubber, and it will crack off. We've also tried using spray-on waterproofing clear coat. We followed a layer of blue spray paint with about 5 layers of clear coat. Although it looks pretty cool and works well at first, after 3 hours of being fully submerged, the on-off switching function did fail, whereas the silicone-treated board did not. Both lights were still on at the end of the 3 hours, but the spray-treated board was stuck in the on position. Like I said before, water-damaged boards still work, but the switching function does not. So if you want to still use a water-damaged module, you'll have to just switch it on or off by plugging it in or directly splicing an on-off switch into the wires. Also, this transistor will get really hot on water-damaged boards. You can see how the epoxy covering it turned brown from the heat. In this case, you can actually just unsolder the transistor and use a wire to jump the larger pad with the smaller pad that's closest to the edge of the board, and then it won't get hot and smell bad. Again, subject your Stratus LED modules to moisture at your own risk. Thanks for watching and good luck.